Welcome, Robert. Welcome, Alan. It's a pleasure to be here today talking with you guys. How are you doing?
It's great to be here. Yeah, it's a perfect day. It's a little rainy here, and so it's perfect to be online chatting to everyone.
Good. So, you guys have made a lot of work, and we have a lot of stuff that we can cover. And let's start by saying when did you find out about the MiSTer project and what you thought about it, Alan?
No, that's a good question. It was, must be 3 years ago, I think. I'd have to look about building it, and it was just a link to the GitHub page, and I.
Oh, we can't hear you clearly, Alan. Sorry. Maybe speak closer to the microphone or turn off noise reduction.
Is that better?
Yeah, it's better.
Okay. If not, I can switch to a better computer. I think I left my headphones in the car. Yeah, I started. I don't know how many years ago, 3 maybe, and I saw it on Hacker News, and I sat on it for a bit, and I ordered all sorts of boards and parts, and I built 10 I/O boards and 10 sticks, and it was crazy because I had never done surface mount before, and I gave them away as Christmas presents to all my friends because I figured my friends have everything, and it's impossible to get a gift. So that's how I started.
Oh, I don't know if everybody else can.
Okay, let me switch computers.
Yeah, sorry, no problem. Meanwhile, Robert, how about you? How did you find about the MiSTer project and what you thought?
In my case, it's more like a project found me. So I was posting about the GBA core maybe 1.5 years ago on Reddit.
Yeah.
And the first responses was, will you port it to the MiSTer? And I didn't know much about it before. And this evening I learned it. This evening I joined the Discord from Classic Gaming and found out about the project, and I would say I never left it after this day.
Yeah, I can imagine. This is you're talking about the FPGA project, right?
Yes.
Yeah, I saw that. It's very interesting because you also were developing a model C# GBA emulator with it, right?
Yes, I've done this for all my cores. I have always developed a software emulator before, just to understand how the system works and to try little things. It's always easier to do.
Yeah, I can only imagine. Specifically, many people wonder about this topic. We'll probably get a lot more into this topic later on after we kind of introduce ourselves. But what is the main advantage that you see in doing that approach, like building the software emulator and then changing to FPGA?
For me, the main reason I did it was I didn't know much about the system at all before. So if I would have started with the FPGA core directly, it would have been a long way with lots of mistakes, and I would need to change maybe the architecture later on. And if I do the software implementation before, I already know what I have to do. I know all the little details that need to be in the design, and it's often if you do something, the second time you could do it better. So it really helps. And for prototyping in software, it's just faster.
Yeah, that makes a lot of sense. And meanwhile, while we wait for Alex, who probably just hey, yeah, he just joined us. Hi, Alan. How are you doing?
Am I more clear now?
Yeah, way more clear, Alan. Thank you.
Okay, I have my MiSTer PC development box has a totally inexpensive webcam that I think has terrible audio. I should probably get a new one. But this is better. Yeah, I just checked, and November 2017, I sent a note to one of my friends, hey, we should solder this together. And in college, I wrote a software Commodore emulator, so I've always been interested in emulation, a C64. But when I saw MiSTer,
I thought, wow, that's really neat, because when writing a software emulator, it's really hard to synchronize all of the different chips and get them to run in the right time. And I thought, well, this would be something fun to play with. And so I built 10 and then 20 boards myself, which I would never do again. I order them all online now. And it was the perfect gift for all of my tech friends who, have everything. And so none of them had a MiSTer, and a few who were impossible to buy Christmas presents for. They played their favorite Zork or whatever.
No, you made their days for certain. Yeah, for sure.
And back then, it wasn't. I don't think there were barely any sellers, so it was perfect. Like, there was no way they could solve it with money at that point.
Yeah. It's amazing how fast this has grown, right?
Definitely, and I think part of Alexei's genius was to make it look like MiST from a software standpoint and from compatibility, and make it really easy to port the MiST cores, because when MiSTer started, it had all of the, stood on the shoulders of every FPGA project that was out there. And then the first programmers were, not that all of them, but a lot of them were more like me, people who just didn't know much, but just could take a core from MiST or from somewhere else on the internet and port it and get it running on MiSTer quickly. I think that's why it's gotten so big, because when I started in November of 2017, there were still a ton of games to play on it. And now it's amazing, with people like Robert cranking out these gigantic systems one after another.
Yeah, I know. And also you've been cranking a lot of updates, of course, updating them and bringing them to the system, right, from other platforms like you mentioned. And now that we're talking about it, how do you select which cores to work on? It's because you deem them easier, like you mentioned, like a good introduction. It's one option, of course. Or is it, I like to have this one running no matter what? What do you feel like, Robert, Alan?
Go ahead, Robert.
For me, I started with the GBA core because I played the system a lot in emulation in the past. So I grew up with this system, and it was the first choice for me because it was missing and was interesting for me, and it didn't seem to be too difficult. So
the word there is sim, or did that prove to be true?
I would say in the end, it has some problems with it that came later on, but from the first look, it didn't seem to be too difficult. So it was a good point to start with. There are always some edge cases, but not too bad in the end.
Okay. You, Alan?
It's funny, when I first started, I made a Google Doc with all of the fixes I wanted to do. And I'd say I finally, 2 weeks ago, may have fixed the first thing that was bothering me. So I have it's a huge learning curve, and all of my fixes were way too ambitious. But I got PPP running and the serial port working on the Mac Plus, and that I had as one of my first things, because I used that Mac Plus core, which is pretty impressive. It's much better after Gerico fixed it last month, whenever it was. But I couldn't get any software on it, and I did all sorts of hacky things to try to get software on it easily, and it was a mess. The other one is I wanted to make the Apple II disk write. I know Sentient, she always says she wants that, but I still have not done that. I'm trying to think what else was on that list. But it's kind of a funny list because, yeah, none of it. So I would say that I had cores and things I really are personal to me, grew up using my Mac, but I'm just so lazy that I just try to do the easiest thing to make the most gain. And that's going out and sending MiSTers to different developers and getting them to port their cores or porting their cores. And just been trying to move up this learning curve of Verilog and VHDL and hardware, which is super hard.
Yeah, I can only imagine. I want to go deeper into the Mac thing later on, but right now I think that what you're doing, I would put it like, which thing that I do makes the most impact. I think that's a different way to put it, but I think that's the effect that it gives. So thank you very much. And next question is before we start like going into the work that you have, because we have so much to cover, but we'll cover whatever comes, and we can do other streams later on. Is what catch you or got you into gaming in the first place years ago, Alan?
I would say that I'm more of a hoarder. I would say I always enjoyed pirating software and hoarding it, and I would say I played very little of it. And I'd say the same is on my MiSTer. My MiSTer is full of games, and I'm probably mostly in Quartus writing fixes and things. And so I think, yeah, early on I had an Apple IIgs, which we definitely need an Apple IIgs core. And I loved, meeting people and doing BBSs and downloading things and filling floppies full of software that I never used.
You, Robert?
Yeah, when I was a child, there was already a lot of systems available at that time. So the Super NES was available, the Game Boy was available, and first PC games also. So I grew up with all of them. I never had a Super Nintendo, but I got a Game Boy very early, and I spent quite some years with it as a child. So that brought me to this topic, and I started programming when I was a teenager, with 14 years or something like that. And then I started to program my own games, and all this led to the things I do today. So I started studying in this topic, and all coming from the gaming.
Yeah.
On the Game Boy early on.
And is there any specific game that you remember or cherish playing as a kid?
There's one very special game. So it was the first time I played Super Mario 64 in the store, and I seen this 3D world, and you can move around there. I was maybe 10 years old when it came out, and it was so impressive. I will never forget this moment.
Yeah, I kind of relate to that, and watching stuff at the shops, and just wondering how it would feel to play them, right? And you, Alan?
It's so funny. We Jamie has been working on the 7800 core, and I've been kind of a cheerleader for her as much as I can, and try to help her out. But my earliest memory was having a 26. Well, before we had a 2600, we had that ColecoVision, or not ColecoVision, Coleco. I forget what it was. It was like the one with the gun and the steering wheel on each side. But then we had a 2600, and it was so disappointing. Kind of when the games were really expensive, and I remember I must have saved up every birthday and Hanukkah present to get a cartridge, and it was Barnstormer, which is a terrible game. And I just remember getting it and playing it, and it was nothing like the TV ad. I actually went on YouTube recently. This whole 2600, 7800 experience has just brought back those horrible memories of that game. But on the 2GS, there were much better. Yes, the Telestar. There were much better games. I love Montezuma's Revenge, which might have been an Apple II game, and Narc was so silly. Yeah. That game is awesome. Yeah, I think the GS version.
So impressive, right? Visually, Narc.
Yeah, it was so good. And we used to hook my GS. We'd take it out of my room and hook it up to my dad. Loved his TV, so he had some crazy rear projection 70-inch TV. That was his, that he put in my mother's fancy living room. She hated that. And so we'd have all the kids over in high school, and we'd play Narc on this gigantic TV. It was a lot of fun.
Yeah, it was always fun to just grab the system and play it on the big system, on the big TV system, right? And going back to that Atari 2600 experience, was there any game that you do like to this date from that era?
No. Okay. No. I don't happen. I think the 2600. I remember my cousin got one later, and she always, I felt, had more toys, and she had, I think, Pac-Man or Miss Pac-Man, which was pretty good. And I was always like, wow, I wish I had that cartridge, but I don't think I could get my parents to do it. And then there was the Crash, and then Toys R Us had the cartridges for $2-3. And I must have picked up a bunch, but I've never really been captivated by any of the 2600 games. And then I did get a Game Boy Advance as an adult when it first came out in Tokyo. I was there on vacation. I saw all these people lining up for it, and I love MiSTer Driller. MiSTer Driller is so mindlessly stupid and great. And I can play that for
It's
hours.
a great game.
Especially, yeah.
And Robert, are there any games that you still keep from your childhood? Like the physical copies from your childhood that you still keep?
I don't have any games left from a childhood, I would say. I still play them.
Yeah.
From time to time.
Which is the important thing, after all. You still play them, which is good.
Yes.
Any you could mention that you can still play and that survived that test from age?
So I played as a child. I played a lot Pokemon, the first one from the Game Boy, and I still remember pretty much everything from this game, and I still play it maybe once every 2 years. It's still good for me.
Yeah, that's really interesting. Have you like ever gotten into well, of course we all have tried to figure out how this stuff works, but what was the short path or the short version that got you into hacking or developing? Was there a clear path, like trying to figure out how the save game works, for example, whatever? It's just from the top of mind. Which was the path that you followed that brought you here in that sense, technically?
So for me, I was always doing some little projects on FPGA development since I was maybe 22 years old.
Wow.
So 10 years ago.
Awesome.
I started doing very little stuff. So over the years, I did some own CPU designs and things nobody would really use. And I did that, and I had no software for it because there was no software for a CPU core that has no system behind. And then I watched a video from someone from Intel presenting that he has done Intel CPU soft core for FPGA. And he said he did this because he can never write so much software in his life that he would do any other processor. Would not make any sense to him. And I thought at this moment, when I develop something like this, why don't I go for some system already existing? It would be better to have software available and not doing development without anything behind it. So this really changed my view on this topic, and I started with my very bad Game Boy core. After this, it's dead now. I didn't do anything about it anymore. You can still find it on GitHub, but it's really bad. Play some games, but it's not a good one. And but it was a good start to look into and see what problems there are and go ahead.
And well, that's quite a story, because you basically, due to your age, probably have been kind of native to this kind of development, right?
Yeah, when I studied, there was a colleague giving me an FPGA board and telling me, "Oh, it's cool, look at it, and look what you can do with it." And he presented some things to me, and it was great. I liked it very much. It was more interesting than the software development I was doing all the time, because that was the topic I was studying. Computer science was mainly software development, but this FPGA topic was so exciting, and I started doing this instead.
Yeah. On that note, Alan, how do you feel about that change? You already mentioned that it's a hard topic, right? But how do you feel from changing from a software perspective to an FPGA developer?
Yeah, it's interesting. I studied computer engineering. I did have one class in Verilog, which I feel like they told me that they somehow passed me, but said my project would never run on real hardware. It's hard for me to think parallel, and it's hard. I mean, when we write normal C code, like I grew up doing, it's, one, or basic, maybe it comes from too much basic as a kid, it's one line after another. And so it's been a challenge. It's funny, I got started with my Commodore 64 because I think it was like 1994 or something. I was still at university, and I had an internship at Apple. I was working on, I think which year was which. I was working on the Ethernet driver or networking stack for the new PowerPC that hadn't come out yet. And my roommate, who's awesome and way better hacker than me, was working on the team that was doing the 68,000 emulation for the PowerPC. And so his sort of like day job was to try to help the person figure out how to, go faster and emulate faster. And then we found, when we were there, a bunch of people from our university who had sort of dropped out, most of them had dropped out of college or they had graduated. They were working on an Apple IIgs emulator that I think became a product that Apple sold, maybe like the LC or something. And so it was sort of all around us. There was already an Apple II emulator and a GS. And that's why we went with the Commodore 64. And so that's sort of how I got into at least the emulation side. And it was fascinating because being just a software person and not having a Commodore especially, and not really doing anything but basic on my Apple II, it was just having to go through every chip one at a time and understand more how a processor works and how the video works, and then sitting there with the video chip, one piece of software at a time trying to fix the bugs. I loved it, and I started doing more and more emulation. But as I said, the problem was, and especially getting that emulator work on a 68,000 was a challenge. It was a fun challenge, but it was hard to get it fast enough. And so now it's the challenge with writing any of these cores, as Robert sort of described, and he's way better at this than I am, is you have to learn a lot about the system. And I just came off that Coco 2 core, and I had to learn. I used one again, like in BASIC when I was 10 or something. So you have to learn how the video works and how everything works. Then you have to be good enough in Verilog or VHDL to be able to start to express it. And then you have to think more like a hardware person than a software person, and think about how the timing works and clocks and how to do everything one cycle at a time. And I'm still finding it really difficult.
Yeah, it's a lot of topics that you cover there, and I'm no way at the level of any of you guys in these areas, and it's always been fascinating to me how an embedded system, a computer, can create such worlds, right? And it's very attractive to, instead of like porting a game, it's easier to think, right? I'm just going to emulate the system. I'm air quoting here, right? And have all of them working at once. But there's so much going into each one of these systems, even the early 70s or 80s systems like you mentioned. I'm fascinated that those systems can be understood by a person and kept in a single mind in some way, because you're jumping between a reductionist and a holistic perspective, right? And which part is it that you're most familiar with regarding this analysis approach, Robert? Is it the holistic, or is it the reductionistic part?
So when I look at let's say the GBA system, because I probably know this the best from the ones I worked on, I would say I have an overview of everything, and I know where to find information I need. And I don't think I have everything in my mind at a single time. But when I go into a subsystem there, a single part, I can understand it again after a few hours, and I can find where was the information. But I cannot have everything at the same time in my mind. I don't think that works. At least not for me.
Alan?
I couldn't hear you, but you just popped back in. Can you say something?
Sorry, I was... we were talking about how the approach regarding what you were saying. Is it easier for you to just see the big picture, or just approach every single chip from detail? Holistic or reductionist approach? How do you feel it works better for you?
I'm lazy, so I usually do the holistic. I try to get as big a win as possible. So I'd say I don't usually worry about every little chip, although eventually you have to. And that's what's interesting is when you look at MAME source code and some of the software emulation, you can often, I wouldn't say shortcut, but you can do something like most all computers have a big memory map, and you can just make an emulation by having one big piece of RAM and maybe trapping out a couple things. Whereas in the hardware, it's more there's usually a big mux or something in the FPGA to decode all of the address lines, and it just gets more complicated. Whereas a lot of times in software, because you just have this huge thing in memory, the default might just happen to work reasonably well. But in hardware, you have to actually know what's going on.
Yeah. And regarding now that you mentioned MAME and also the difference in approach in a way, MAME is this huge project that has been there for like 25 years, and the approach is usually high level, right? You emulate the things and you make this wrappers that show you the memory map, connect everything, and they don't bother in certain details like they use high level emulation, for example, for video and audio. I don't know. It's my perspective from the little things I've seen. But how do you feel MiSTer can help fill that gap in documentation regarding these subsystems that are not properly emulated?
Well, I'd say, well, it's interesting. The FPGAs are still emulation, and especially the computers we've been working on recently, it's the bus situation is really hard because normally you set up a computer and you put 5 devices on a bus and a chip select, and you write something on the bus, and then the chip that wants it picks it up. But the FPGA, you can't really do that, so you end up with this huge mux that has the chip select, but then everything has its own wire, and you sort of put an if this chip select grabbed it from here, if this grab it from there. And so it's an interesting difference. So I'd say that in a lot of ways we are documenting things better and we are getting closer to the real chip. And it's amazing sometimes with some of these components have gotten so good. And it's so neat because unlike MAME and some of the other emulators, you really often can just take a chip, especially a processor or a video chip, and you can grab it and say, oh, I want to build, a laser 310 because it uses the same graphics chip as the Coco. Oh, but it didn't use the same processor, uses this other processor. And you really can get very far by just grabbing a couple of pieces. And I haven't seen that in software so much. It's really hard software to move things around. But the interface, and maybe it's the API issue, because most of the chips have the same API as the spec sheet, as in the same pins, more or less, it's really neat and it's super fun. So it should accelerate too, I should say. And I don't know if Robert agrees with that, but it should accelerate. Like if I wanted to build a 2GS, I would grab Robert's 65816, and I think I'd be, the biggest part would be done probably.
And what do you think about that, Robert?
Well, for me, systems I worked on, there was no component available I could take. So I always had to do it myself. And I also like to do that. So I like to do the CPU design myself instead of taking the existing one to understand the details of it, the details of the timing and all related things there. And I don't think I can understand the full system if I take the existing chip, but it really depends on the one developing it. So I'm really bad at looking at existing solutions and understanding them. It's really difficult for me.
I can relate to that. Yes. It's easier for you to analyze it and then implement it.
Yeah, I feel more comfortable implementing things I've understood, and I see what I have written and I can read what I have written, but I have large problems understanding what somebody else has written. It's difficult for me.
But there's a interesting difference in that from a software development perspective. Like you always end up using subsystems or libraries, right? There's a fine line between using somebody else's work as an interface and understanding what it really does, right?
That's right.
And well, talking about this implementations that you've been making, there's there's a lot of ground to cover because you've been working on this for a while. And for instance, you've been working right now on save states and fast forward and rewind, Robert, for several of your cores.
Lately, last time for the NES core, it was save states only.
Okay.
But before I also worked on the other features. Yes.
Yes, I've seen that. How does that attracted you, and how have you been approaching it for different cores? Has it been similar approach, or has it been very different for each one of them?
So I have done this first for my own core. So for the GBA core. So it was simple there because I know everything of it. So I could do it there. And then I started doing this for the Game Boy core. And it was also quite easy because I understood the Game Boy as I made an own core a year ago. So I could understand what it does and what it should do, and I already knew what to do, what is the picture behind. And for the NES core, it was very difficult. I have realized that, and I needed a lot of help from Jamie because I don't know anything of the NES, and it has so many little details, and it was very difficult to do that at this core. So in the end, I think it went well, but it was so difficult that I'm not sure I would do it again for another core. At least not if one of the main developers isn't helping to understand things.
Yeah, because you're just like tapping into everything basically, right?
Yes, you need to look into every part of the core.
Yeah, otherwise you're sure to cause problems, right? Sorry.
Yes, and you don't know, do I need the specific part here, or can I skip it? And if you take everything, it's too much. You cannot do that. So you need to find a solution that fits, but you really need to know the system, or at least need help from someone who knows the system. Otherwise, it will not work. You cannot take a core that is absolutely unknown to you and implement the save states there. It would not work.
And how difficult do you think it would be to take your experience and like make uh what to do for other developers to implement that on other cores?
So I would say with the modules available, if someone would take them, I'm not sure if they're easy to understand, but if you take them, it's mainly work to do. So it was I think it was again 3,000 lines of code for the NES core. Now to add the save states, and it was about the same for the Game Boy. So it's a lot of code to write, but the things to do are not too difficult in the end if you know the system. But there's one important step. The system must be able to be paused. And that is something that not every core has. I would say maybe every second core only has the possibility now, because you need to design the core from the early on to do that. And if that is not done, and it was done on the Game Boy and also on the NES core, but on others it's not done, then you need to do that first, and it's much more difficult than adding the save states. So it doesn't sound like it, but adding a pause functionality is really a huge step.
So you would recommend that first they implement the pause or design the core from scratch to have this pause. I saw that you have like this signal to enable the RAM chips and everything on the Game Boy core, right?
Yes, so if you design new, adding the pause functionality is very, very few overhead, and it costs nearly nothing to do that. I have done it now in a way that is really simple on the Lynx core recently. and it was very easy to do it. If you know from the very beginning that you need to do it. But if you are done with the core, adding it in can lead to various bugs. And you cannot say if you changed the logic with it, you only need to miss a single part, and it's very difficult to edit later on.
I can only imagine, of course. And what was the inspiration to get this working? Why did you do it?
So for the NES core, there were, I think the main inspiration was the amount of requests to have this feature. But I'm not familiar with the NES core, and I never played it before I worked on the save states. I only made a small change some months ago, but I didn't have a single game on my SD card for the NES core. So know much about it. I never played it in my life on the real NES system. It was a requested feature there, and I've done it several times before. And one of the main reasons to do it there was that most games cannot be saved, and I thought maybe it's worth working on it.
Yes, it's a huge feature for a huge chunk of the community, and it will certainly attract speedrunners and other communities that were requesting this, right?
Yeah, and also one thing to notice that when I started it, I knew that the NES core was prepared for the pause feature, so I thought it can't be such a huge task. So it took me maybe 2 or 3 days for the GBA core, and I knew that system, and it wasn't much more for the Game Boy. So I thought maybe a week and I'll be done with the NES core save states, but this didn't work out. So I think it's 3 or 4 weeks now. Still okay.
Yeah, it's a lot of work, and there's a lot of detail to go into here, but I unfortunately we have a lot of stuff to cover. I'm sure we'll get back to this when we cover fast forward and rewind, because that's also very important. But I'd like to ask Alan about MRA and why is that needed and what do they do?
Yeah, before MRA, we had these little scripts that would take ROMs. Let's back up a second. If you look at an arcade board, a real board, generally there are a bunch of ROMs, multiple ROM chips across the board. And when people for AIM and before started to preserve the ROMs, they would save them and put them in a zip, usually with 5, 6 ROMs, whatever it is for a game. MAME, I never really, until I got into this, thought about how MAME handled this. I just used to play MAME. But they have in the code, kind of hard-coded into every core, a list of the ROMs, a list of the CRCs, and all the different variations. And so when we were doing MiSTer in the beginning, or when I came to the project, other people had done it. They just had a shell script, a batch file for Windows and a Linux shell script, and some only had the Windows one, that listed ROMs in some order. And a lot of times, because of the way you want the memory map to work, they would list the same file over and over again. And then they would concatenate it into just basically one big ROM. And then on the Linux side of MiSTer, it would then send that ROM file just 1 byte at a time to the FPGA, which would then often put it back into, say, the 6 original like simulated BRAM ROMs that the original Pac-Man or whatever it would have. This was just kind of a mess, and Bruno Silva did some amazing work on pulling all these scripts together, and he had this crazy Windows batch script that he auto-generated from some Visual Basic program that he could make not just Pac-Man, but every variation of Pac-Man, and dump out all of the ROMs. And so then he and I went through and I added all of this functionality to every single core so we could load a ROM. So if you're playing Pac-Man, you could play all the alternates. But it was just such a mess, and it was hard. And I felt like it was just annoying for everyone. Like you want to be able to just grab MAME ROMs and drop them on the disk. And so we made this MRA, which stands for MiSTer Arcade format.
Mhm.
Jamie was she kept pushing me. She's like, fix this, MAME's terrible. And until she really pointed it out, I didn't even understand how it was just all hard-coded. And so in a way, MiSTer is neat because we document it, instead of it being in the source code, it's documented in these MRA files. And it means when you go to build a core, and one of the best things that happened, and I think maybe Alexei did this, I don't remember who pushed for it, but we moved the dips out of the core and into the MRA. And that's amazing because usually the dips, you read the doc online and it's always like, is it active high, active low? Is it wrong? Do these dips match this ROM set? And so it's really nice to be able to just edit that text file 10 times without rebuilding the core. Because rebuilding a core, even a small arcade core, takes 10 minutes, 6 to 10 minutes, not longer. So anyway, that was MRA. And I started and hacked and slashed the first versions of the C code. Bruno made the first MRAs. And everyone else now has just been adding and adding and adding to it. And it's really fun to see. And it does a lot of things. And then we just recently, the DRAM went in. And then Jimmy Stone and I have been working on adding score saving. And we do that as well by putting the configuration in the MRA, which is really nice.
That's really interesting. I've been a part of a dumping union for a while. And I document arcades, and I want just for our public to understand. It's when you have an arcade PCB, it's a dedicated computer that was built in many of these early cases specifically to play that game, and it was just an iteration between the family of products that company made, right? So they are custom-made computers that are built to only run that software, and maybe you have the region variations or hacks or bootlegs, right, around that area. And the MRA allows you to, if I see it like the FPGA, you configure it with the core, and the MRA configures the core, right?
Yeah, and it's neat, and one of the other things you can do in it is we added the ability to put patches in. So really, it's just really nice because it's very flexible. Because some of the patches were done like in the shell script because you could just do. I remember Bruno saying to me, "There's no way you could make everything work," and I'm like, "Well, there's only so many arcades that work on MiSTer now, so we just have to go through one at a time and add whatever functionality we're missing to get all the arcades working." And it's nice because if someone wants to do a hack or like HB MAME, because the way MAME works, since it has to know about all the ROM files and the CRCs, you can't just drop brand new ROM in. But this is more like original arcade board where if you want to make your own version of Donkey Kong with the vendors reversed, then go ahead and do it. If it runs on the real hardware, you can make an MRA to do it. And the neat part is if you just change the sprites, you can either just pop those sprite ROMs in separately and use, kind of merge them together, use the old ROMs and the new ones where you need to, or you could even just patch. If you just want to fix some bug, you could just put a patch in, and you can have 3 versions, 3 MRA names that are really small that, each one's slightly different. So I think it's
It's just a different description. Sorry that I interrupted you. Of the same. When you do this in MAME, you have to either run the command line version and ignore the CRC errors, or if you're using a GUI, then you're screwed, like you mentioned. But this is really dynamic in that sense. I really liked it.
Yeah, and it just came out of my laziness, and Jamie kind of really pushing to do something better. And it's great because it's just most of the work was done in software, so it was not very hard. And then we had to go back through and redo all the arcades to put the dip line in and remove the extra ROM loading. And the other thing that allowed us to do is somewhere in here we added, and again, it was just nice once you have, and the reason I love MiSTer is Alexei's just put so much thought into the framework, and because you have this framework, it's fun to watch where you add one feature to the framework like MRA or a feature in MRA, and then you can just use it everywhere. And it's just fabulous. So one of the things that we realized is, okay, once you have some ROMs, you can just inline put your own kind of fake ROM that's just the number 1, 2, 3, 4, 5. And then we were able to do things like merge all the Pac-Man variants together. So if you have, or Space Invaders is one I worked on for a long time. I finally got it out mostly. But Space Invaders was a board that was used over and over and over again. And then it was almost all the same, except they would wire it slightly differently, wire the input and output ports differently, or they would add a different soundboard. And so you could have 6 or 10 or 20 soundboards hooked to it. And the neat part is in the MRA, we can just put under a thing that says, oh, this is board configuration 1, 2, 3, 4. And that's allowed us to take from, I forget how many we had. I think we went from 100 and something arcade down to like 40 and then back up to 100. But it's just really nice. So now when we have a new framework, we want to do something, we can just recompile Pac-Man once, and that affects, I don't know, 26 games or something like that.
Good. And how do you feel this could help improve the documentation side? Because, many of us use MAME. Like I have, for example, a Space Invaders PCB that is broken right now, and it has RAM issues. How do you think, right now I go to MAME, I check out the source code for Space Invaders and try to figure out the memory map and which ROMs are there, which are relevant. If I could use a test ROM, for example, which is an issue I'd like to talk with Robert and you later on. And how do you think MRAs and MiSTer in general can help people that are in such situations, or like in 30 years want to know how something works or how it was? Because there's so much problems documenting how PCBs really were made and assembled and how they could be repaired. How do you think this effort helps in that regard, or how do you think it could help?
It's still an emulation, and I think at some level, the MRA, I wish that the DIP situation was a little closer to the original board, so I'd say that it's not great. There is a really good test ROM for Space Invaders, so you should go ahead and build that. And I have sat there and modified it for almost every other variation, like maybe 5 other variations of the board to try to figure out how the sound worked. And I did ignore the CRC errors and run it on MAME and to make, sanity check that I had things working. So I think the difference, it's still going to be a hunt. Like, you're going to look at MAME, and MAME does some things really well, like the inputs and the ROMs, the DIPs are really well documented. But then some things are going to be well documented, maybe in probably not the MRA, but if you looked at the Space Invader core, stuff still gets complicated. Like, as the downside of putting all the different Space Invaders into one core is it gets kind of ugly and it's hard to document the code well. And so I think it'll help. Definitely more people looking at it and thinking about it to help. There was Vortex as a Space Invaders clone, has this really strange video circuit, and it never was in MAME. I think it might be now. Mike Coates was like looking at it, and we were on the MAME Discord trying to figure it out. And he finally got it to look, one YouTube video to watch, and he got it to look like it. And it's a really weird color hack where, Space Invaders is black and white, but they have color by doing an overlay or something strange. And they did, I don't know, they hooked some resistor to some other thing. Some things turn purple. I don't know. It's very odd. So it'll help. I think if someone has a broken Vortex, this might make it the first time it's been documented.
That's really good.
And all these arcade schematics have errors in them.
Yes.
So I think it helps.
Yeah, exactly. That's a sore point in general, that it's really, really hard to find good documentation, because each one of this is very different. Unlike I don't know, a Super Nintendo, where yes, you'll have problems, but it's like there are 10 revisions and that's it, right? Not like Space Invaders, where it's only one game with tens of hacks or tens of different boards, or the Midway and the Tato boards and 3 layers or the T configuration, all that stuff. It's a lot of things to compress into a single thing, right?
Yeah, and the computer cores, I like working on them, and they're sometimes a lot easier because, like, the Tandy has schematics and books and manuals, and here's how to program it, and here's how it worked, and here's how the joystick port works, which is so weird on the Coco. Anyway, so it's just like there's so much documentation. Then you go back to arcades, and on the one hand, they're so much simpler. So they're often, not all of them, of course, but they're often a lot simpler to do. But there's so much less documentation.
Yeah, It's it's a real problem. And talking about the ROMs and the configuration, I know it's not the smoothest of jumps, but Robert, you mentioned that you use the open source BIOS for the GBA, right? Could you talk us about why BIOS is so difficult to replicate in an open source environment and why that's important?
So for the GBA, the open source BIOS is included mainly for users who start with the core to have something available.
Okay.
If you go in depth, you should probably exchange it for the original one. And the main reason for that is that the BIOS is not only used for booting the system up, but it also contains some functions, mathematical functions or some operating system-like functions. And whatever these functions are called, the last value is kept on the bus when it returns. So if you exchange the BIOS for something else and the game depends on this last value, it will just have some strange behavior. So it cannot work without the original one. It's very difficult for the Game Boy Advance.
And I think it's not only an issue for the Game Boy Advance; it's an issue for a lot of systems, right? And this is a real headache. Do you think that it's important to create open source replacements for these BIOSes, like I don't know, the PC Engine or cards, or like the Game Boy Advance and for instance the TMSS from the Genesis? What do you think? Are they necessary? Do we need these replacements?
So it would be great to have this replacement, but I would say for the systems that really need them. So for example, the Game Boy Advance really needs them, and they really need to be completely exact. So from the timing wise, so the function must take the same time. So otherwise the game would behave different. And it must have the same code, otherwise the game would behave different. So if you write an open source BIOS, it will have other code, or you just copy the code. So I'm not sure how that would work at all to have it open source and 100% accurate. But for systems that don't need it at runtime, like the Game Boy, I would say it's much easier to do it, because it's only run at a startup, and you know what the status must be when it's left. So it's better to do it to have open source version there. But I don't think we get an easy replacement for systems that call the BIOS at runtime. That will be very difficult.
Yeah, it's the whole system is like it's like the I don't know how to say it in English. It's the piler that keeps everything running, right? And it's timing and function dependent. I imagine the PlayStation is kind of the same thing, right?
I cannot say.
And what about the
PlayStation?
Lynx? The Lynx does have a boot ROM, but that from the name tells me it's different, right?
Yes, on the Lynx it's only for booting up, so it could be replaced. And if you look at some emulators, they also have code inside where you could skip it.
Right.
It doesn't take much time, so there's no real reason to skip it, but you could have a Lynx core that is completely open source without any proprietary software.
Yeah, I see.
It would be some advantage to have that.
And well, the
I don't know how much.
Yeah, sorry, Alan. Please.
I'm sorry. I'm just gonna type in like I wish that the more of this would be open. The original ones would be open source. I think like the Lisa, some of the original stuff is coming out. I wish the Commodore stuff would come out, but and just be put in the public domain. But it's also a little silly. I mean, we are running all of these ROMs that are copyrighted. So I'm not like, if you're going to run Game Boy Advance, the next thing you're gonna do is grab Zelda or something. So I mean, I don't know how important the open source ROM is.
Yeah, I understand. I think that the only the importance is that you can separate everything on a release basis, right? And have the user jump in like plug and play instead of how if for instance, if I want to be fully legal, just I'm going to say that's a position out there, and I want to play my GBA games, I can dump them easily, right? I just buy the hardware to dump, which there are commercial versions out there, or build my own dumper and go. But dumping the BIOS from the GBA is something that is way more difficult, right? In most,
Okay, I guess
yeah,
so.
you have to attack. And in case of like the, I don't know, PC88 or X68000, I can just grab my EEPROM breather and dump it and get done with it and have as many versions as I want, right? So I think that's the importance in terms of like a project, not like a user, to have it easier to set up for everybody. But I fully understand what you mean. And in terms of that, the boot ROMs in these old computers, like the TRS-80 that you were working on, the Coco, are they very different in that regard?
I'm sure I didn't do the right thing legally with them.
No,
but,
no, that's not that what I meant. I mean, like, for example, for the serial support, do you need dumps from controllers for this to work? Are they like the BIOS that you need to have them at runtime, or are they just like boot ROMs that?
I'd say the computers, and this is probably an overgeneralization, but I think the newer the computer gets, the more it's separated from the hardware and from the exact ROMs. So the Mac has been interesting because when I started looking at the emulators, trying to see, can I use an emulator to help me figure out, to document it or whatever, like most of the emulators, MAME's actually getting better, they're changing it now, but some of the Basilic and, or however you say it, and Shapeshifter, they just patch, they have drivers for the video. They don't have a video card, they don't have sound, they don't have almost anything implemented to emulate any particular hardware. They just drop in a driver that works on the Mac, and then they just have it native. And it's interesting. So there's very, very little hardware. Maybe the processor is emulated, almost no hardware. So I think when you get to newer computers, it's a lot easier to replace big parts of it, because you think those, it's all meant to be in a driver sort of scenario. So they meant for the hardware to change.
I see.
And the timing doesn't have to be exact.
I see. And regarding the Mac Plus, you mentioned that the floppy support, and you want Coco to have disk support. I don't know if that means like I guess it's a floppy drive support and not a hard drive. How do you feel about that magnetic media, the flux dumps?
I don't know how I feel about it. The Steadyman did the TRS-80 drive and did an amazing job with it, and then he went on to build strange computer. I forget what it was called. That's kind of like a typewriter computer, and he did the floppy support on that I think was harder. And he was going to do the Coco. I think at some point he'll get to it, hopefully. I think it's very similar to the TRS-80 because it's another TND drive. So hopefully we'll get that. And there was a hard drive for the TRS-80 and the Coco. I think it might be implemented on somewhere. I think I saw it. So I might, at some point I might look at that too. But I don't know if the hard drive's that important. Floppy would be, yeah, I think it's kind of key for Coco, actually. I think it'd be really important.
Floppy, I'm guessing that you need like the firmware, or it would be like a high level support for.
Yeah, that we had the firmware booting. The Ana Coco, the floppy is a cartridge with a ROM in it, and I think I was accidentally booting that when Pierco built the original core. It was just mapped instead of a game. He had the DOS, and then attached to the cartridges, a floppy controller chip, which like I said, I think is the same one as in the TRS-80. Well, there were a lot of cartridges, right? So they had 5 cartridges that were different versions with different controllers, and some worked better than others. And then, so there's a ROM plus the disk controller, and then a cable that would plug into a disk. So, so the challenge as well is in an FPGA where you don't have software is then to decode the different emulation disk formats. So you have to, on the one hand, make the computer think it's talking to a disk drive, but then on the other hand, you have to parse some kind of file, and just parsing files and dealing with not really text, but kind of textual type of data, binary data, is just hard in FPGA. Because normally, if you think about a computer, you have a soft core, you have a processor, and then you write software to So if you're just going to do it in an FPGA, it's hard.
You may.
That's why a lot of these disk formats aren't supported.
Yeah, and regarding that area, then I think it's going to be really difficult. I've been into flux dumps for later computers, like late 80s computers, PC88, X68000, and MSX. And the flux dump, that, of course, that floppies are an analog medium, right, instead of digital. And our current dumps work on the basis of unmutable digital data. And this works for cracked images. But if you want to play like the original dumps from these games, you would need to have support for either flux dumps or some other format where weak beats and all these details, the damaged tracks, and would just like crawl up. Do you think that would be targeted in the future, or no idea? Or
no idea. I mean, what's been fun about MiSTer is we, just get something out there that works, and then someone who really cares about flux dumps or cares about something else can just work on that part
and expand it.
And so I wouldn't say it's never going to happen, but we would just like to get it to play a simple cracked disk to start with. But it doesn't mean that someone can't make it better. And as you say, the analog doesn't work so well on FPGAs. I mean, that's a weird statement, but I mean, FPGAs are digital. So sometimes obviously we have sound chips working, but analog sound, analog hard disk drives are going to be a challenge. But again, it's like when you actually model the floppy controller, things sometimes get a little easier than you would in an emulator. And so, things are possible. And it's amazing how much stuff just works when you just follow the spec on each of the chips and hook them up correctly.
I can imagine it's magical, right?
Yeah, when it first works, like when I finally got the serial port for the Mac Plus working, it was just, that was.
Have you plugged anything into that?
No, I just wanted. What I did at first was just turn it on console mode, and it just hooked up to it's actually not really set up well to go. I didn't put enough support all the baud rates, so I can't plug it into a modem just because I was lazy. But no, I got the prompt on Linux on the MiSTer, and I typed ls, and I was like, whoa. and then when I got PPP working, it was a mess at first, but now when it's solid, it connects immediately, and packets fly. It's just, you see the little fetch dog moving.
That's amazing. I can only imagine how it feels to have all those change of events working all of a sudden, right?
Yeah, and it was like that. It was like boom, it started to work. What's interesting in talking about what you were saying, documentation, the VMAC or mini VMAC or whatever made a weird software assumption that I didn't understand. And so for a year, I couldn't figure out how to get a byte off the serial port. I couldn't see the Mac writing to the serial port. And it's because they have a mode in the serial port write to the registers, and they have a mode to send data, and the mode to send data is quicker, so you can send less. If you had to send it the other way, like writing to a register, you'd have to, I think, write like 2, 3, 4 bytes to it. But the software emulation just shortcutted it and said, if you're writing to the serial port, make it look like a register write. So I kept putting signal tap and bug into the hardware, looking for it to write to that register, which of course it never did. And that's my fault for being stupid and not really reading the spec well. But it's just amazing. And that goes again to the documentation problem. So by just staring at that code, and of course, once I knew it, then I saw the shortcut in the code. But it was interesting. It was like, in a way, just like actually not preserving the Mac that well, because they did a weird shortcut in the software.
Interesting. Yeah, and that's something that you only see in retrospective, like when you're going into the detail.
Exactly.
And talking about having something work, not all of a sudden, but after so much work, Robert, the Link score is pretty recent, right?
Yes, it was 2 months ago, I would say.
Yeah, and you brought a really fully working core. I would say really fast.
I would say for the links, it was quite easy because the links is not really dependent on any accuracy timing-wise. So if you got the main CPU working, which is just a common CPU, so it's nothing too special, or the 8-bit CPU, and that's mainly it. If that works and some registers behave like they should, most games are running, and it's just the output to be done. And that's really different from, for example, the Game Boy Advance, where a lot of subsystems like direct memory access and other parts are working in parallel and taking resources, giving them back, and that was much more difficult to get all the corner cases right. And in the Lynx, every part of the system can just set the other parts to pause, and you can look at it alone, and there's not much in case of corner cases there. And it was really easy compared to the Game Boy Advance, I would say.
So
that made it faster.
So it kind of felt like vacation in a way.
No, not really. So it's when I work on something like this, I usually do 8 hours a day on it. So I have my day job, and afterwards I start working on it till it's late on the day, because I want to get things done. And when I have the first thing done, I scale this down. So when the first games run, I go down from 8 hours to maybe 4 or 2 a day to get some time back for family and other things.
That's a lot to juggle.
But when I'm working on something new, I'm too focused. I cannot stop then.
But that feeling is really good, because I imagine that you need to be really focused and no external inputs, and that's really difficult in the environment that you mentioned, because you have so many other stuff to worry about. But I'm glad that you were able to focus those hours and build this with passion, right? Because if I imagine that it's like a deck of cards on a cloud, right? It just puffs and falls down if you have to work on something else suddenly, right?
The worst thing is if it gets evening and there's something I haven't figured out yet. So it will be a long evening then, into the night until I find it, because I cannot sleep before. So it's really difficult to be deep inside such development for me.
I can imagine. And talking about that, do you have the real hardware close to you and analyze it, or work from documentation? What's the best approach for you? And talking about that, well, I'll ask the next question further down.
So for me, I have the hardware here, but I only use it really to compare. If I have a problem in a game in the core, I want to compare to the real hardware. So when I started development on the Lynx core, I didn't have the hardware here, but there's quite good documentation, and there are existing emulators, and I have written my own. So when I notice something odd in a game, I try to find out what should be right. Compare that with the documentation. I'm not the right one, and I'm not experienced with debugging on real hardware with oscilloscope and other things. That's not what I'm used to do. I have done it a few times on the GBA core on games. For example, this one football game that nobody has gotten to work in emulation over years. I have done this one time, and it costed me so much time to find this out, and it wasn't really fun to do that for me. So I'd rather develop things that are known, how they should work, than to find out the details from the real system.
I can imagine. And regarding that, do you feel well, this is more like an approach thing. Do you feel that after you finish, for instance, the Lynx core, there could be discrepancies in timings or other stuff, colors or sound or frequencies that would need to be backworked from the output, from measurements, and then fixed in the core? How do you feel about that?
I would say for the link score, there are probably some things not 100% accurate at the moment. The main reason for this is that for the links, there are no test ROMs for timing available. So I would need to do them myself, or I would need to do measurements myself, and I haven't done this yet. I've worked mainly from the documentation, which states most of the actions really accurate how they should behave, and I have gotten the timing from that, but I cannot be 100% sure. It's for the links, it's not too difficult because many games really depend on the timing when, for example, for the speed of the game itself. You can see a timer. I really use that. So some games have a timer, and if you run, for example, the core at double CPU speed, the timer goes down 1 minute in 30 seconds. So if I time it, if I see that it really runs 1 minute when it ticks down 1 minute, it's not too far off. But that's the best I can say at the moment, really. So otherwise, I need to write test ROMs for it. On the other hand, I haven't gotten any bug reports on inaccuracies for the link score, so I'm not sure how much time I should spend with it. As I said, I'm not really pushing into debugging on the real system. So I would say time will show if it is really required there. On the GBA core, on the other hand, there's a really good test suite available from MGBA emulator developer, and it has so many tests for timing, and you can really see what part is okay and where are still problems. And this helped me a lot getting the timing right.
And well, now you touched exactly on one of the subjects we were going to cover, but what do you think about test ROMs? Because this is an area that needs a lot of work, and only people like you can make good test ROMs because you know what you want out of the system, right? And do you think more emphasis should be put into getting test ROMs out for every system, and what should they include?
So I would say it's not really the case that only the developer can write the test ROMs. So for example, for GBA, there's a quite active development community. And there are some developers there which are focusing on finding out details from the system. Just recently, they posted some test ROMs they found just made to make every emulator available not working with them. So it's like a contest. And it's usually the emulator developers work on it because they need it.
Yes.
If there were test ROMs available, so I would say if you have the test available, writing the code is so much easier. And if you have the test already, you are not you don't want to write another test. At least I wouldn't do.
Yeah, it's not something that you look forward to, right?
Yeah.
And
so I have done it a few times. I have some parts of this test suite. I have written some additional tests or improvements for this, and it's integrated now. But it's really a lot of work, and it doesn't bring you much forward at this point, because when you find it out, you already know the solution. So to bring this also in a test ROM, to have it preserved for the future, is another huge step. It's not like you find it out and you get it for free. It costs a lot of additional time to have it in a format so everyone else can use it in the future. So I would say if there are more people working on this, more people working on a system, it's good to have this work divided up.
Yeah, for certain. And how do you feel about somebody bringing up like, hey, the test runs shows a 0.1 difference in between your core and the real hardware? How does that feel, and does that help?
So at the first moment, it's like you're getting
Yeah, I
smashed.
guess.
So you get a response, it's not working. But at the next moment, I'm really interested to look into it. What is it now? Can I find it? And often it is something. At the first moment, you say, "How can this even work?" And then you look deeper into it, and it's one of these situations where where I can't go to sleep until I find the solution for it.
Uh,
So
Alan?
it's
No, sorry, I thought Alan had something to say about it. Just go on, please, Robert. Sorry.
Oh, test ROMs? No, the test ROM thing for the 7800 was interesting. We found just Googling a developer who it's the 7800 basic project, which is actually really cool. Everyone should start playing with that, making their own 7800 ROMs. But he was amazing. He made me so many test ROMs, and every time she had a question, he would make another test ROM to try to find an edge case. It made such a difference.
Yeah, and this brings up like so much information regarding what the system actually does, right? Because you're on the inside.
Well, I would say with the 7800, I think we still don't know what it does, but we have the schematics too. But yeah, no, we definitely a lot more knowledge.
And Robert, they were asking if now that you went to the GBA core, if you'd do the Pocket Station or consider it.
I have looked at the Pocket Station. I didn't knew it before. I've seen a video of it on
Okay.
YouTube, and I decided it doesn't have any good game. So I'm not really motivated to work on it.
Yeah, I can imagine. Of course. And well, back to test rooms then. Yes, I can imagine it feels like an attack, right? At first, I know it's not the intention, but it kind of feels that way. It's difficult to separate it from the personal work, right?
I know this also from the other perspective, because at work I'm searching bugs for the software development, and I'm always the bad guy finding the problem.
Yeah.
And on this side and here, I get a report, and it's not feeling good at the first moment. I would say it's natural. It's not feeling good if you are taught there's a problem in your core. But on the other hand, it's great we have this community to find these things, because otherwise I wouldn't have found it, because I wouldn't have searched for it. So it's really good we have this, and people are working on this, finding these little details of the systems to make them better.
And do you think there's a better way to communicate that first approach in from both parts? Something that we can help improve as a community?
I would say it's fine.
Okay.
Also, it's not an issue that I would feel bad about. So looking into, let's say, GitHub and finding a bug report, I wouldn't say it's bad in any way. It's always better to have these things and have them in a proper format. So it's really good to have this.
Yeah, because from the outside, I understand that it can feel like nitpicking, right?
In some parts, it may look like this in the first place. So, for example, I had one tester for the GBA core who was testing all those rarely used games and finding every flickering pixel or single pixel with wrong color. And it was really annoying sometimes. But in the end, I found so many problems with that. And it was so great to have this help. I will I would have never gotten to this point without such support.
Yeah.
So it's one reason I stay with this project, because the community is there. So I would, for example, I worked on a Nintendo DS core, and I couldn't bring this to the MiSTer board. It's really not possible with the memory requirements from the Nintendo DS. So I bought another board which is more powerful, and thought I would develop it there. But I realized there's no community, so no one will find the bugs. It will never get a good core. So it's really useless for me to work on anything else where no community is there. So I really appreciate if people are testing and reporting problems.
Yeah, it's like shouting and to the vacuum, or like having a community support and feedback, because it gives purpose to your work, right?
It's also a preservation of the work, because all those little projects I've done in the past, they are away now.
Yeah.
They are maybe somewhere on my hard disk, or even not that anymore. But these projects, they are used by others and
Replicated.
they will remain.
Yes. And used, right? You know people are using your work.
Yeah, that was also one thing in the past when I did a project. I always said it's a good project if it's used as much as I spend time developing it. And I would say, for example, with the GBA core, it's probably used much more than I spent time developing it. So that's great from a project perspective and working on it. It's really motivating.
It certainly is. How do you feel about that, Alan?
Yeah, I agree with Robert. It's not interesting to me to work on things that people don't use. And this project, as community grows, has been getting much more interesting, much more fun. And as well, one of the things that maybe we could talk about is beginners and how to get started. I've been sort of kicking around some ideas. I made one video a few years ago, but I've been thinking about trying to put together a Zoom workshop or something. See if we can get some more people to just start a Hello World or something going. So I don't know, I don't know how we questions maybe in the side channel. What people think about that.
Yeah, I think it's a huge topic, and it's a good time to jump into it. We have so much more to cover on the work that you've done, but let's go into that, because that's something that most of our audience will probably be interested in. And you've worked in some tutorials, right, for MiST? Could you tell us about that?
I took the MiST tutorials and when I didn't know anything, and I ported them one at a time to MiSTer. And I would say the port for me was actually useful. So I'm a little unclear on whether the MiST tutorials that I've already ported to MiSTer are as useful for the community, or whether it was the action of doing it. They're pretty old and they need to be updated to the latest. So I've been thinking about taking that repo and documenting it a little better, and starting with maybe what to install, how to install, what the parts are. But I kind of think, given we're still in a pandemic, that maybe we should just do a Zoom and have everyone start it, download the software before the Zoom, and we just start compiling some things together. What does everyone think?
Yeah, I think that's really valuable. What do you think, Robert? About how should we approach like nurturing a community that helps others start in development? What do you think are the main parts? Because right now, for instance, I know I don't have the time, and I believe I don't have the talent to help directly in course, right? What would you tell somebody like that? What they need to like, from the perspective of, you need a computer, you need this kind of software, you need everything in this toolchain installed to just like build one core. What would be the steps that you would give a beginner that wants to get into FPGA development and helping out? Which the path that you'd show them?
So that's really difficult for me. I'm not really a good teacher at this point, I would say, because I have the methods I work on are not really useful for someone starting from scratch and starting without any experience in this area. So I would need to come back and what I did in the past, and this first step. And I think the first steps are not. I don't think it's good to work on existing cores or getting a new core as the first step in getting into FPGA. I would say the first step should be something really simple, like getting LED blinking on a board and things like this.
So
This is the way I started with, and I think it's a good way to come into thinking how this hardware design works. But from this, the next step, I think it's experience from that is required there. You need to work on it.
So do you think I imagine like two paths from what you're telling me. One would be to have like a tutorial where you ask people like to implement a very simple core of something that's already out there, but that could teach the basics. That could be a path, right? That would of course wouldn't feel so accomplished from the outside, but could give you the basics. And the other would be to just like jump to the water and jump into the deep, right? What do you think about that, Alan? Because documenting is and making it accessible and keeping it up to date is really a lot of work, but it's something that's needed. What would be your thoughts?
I started by adding the dips before we had the MRAs, adding the dips for Donkey Kong, because Donkey Kong had been hard coded to something crazy like 6 lives or 8 lives. And wow, did I make so many stupid errors in my first patch. It was just totally useless. But I found bugs that way too. And so Jimmy Stone, as I said before, has been one of the things early on my list was to do the save the high scores, and I had a idea, and I finally wrote a state machine and wrote like a real piece of code in Verilog to do it. But then Jimmy Stones has been going through and putting that into all the cores. And again, he is also a software engineer who's just starting out. And it was a good project because I think by the end of this, when he hits every arcade core, he'll really be comfortable, and maybe he could then start, I don't know what he wants to do, but could start a new core. So I think both, like you're saying, I think some tutorials that are like the blinky lights, and we could blink the lights, or we could do some video. I've been thinking maybe we just get your name on the screen, or we make the screen red or green, and do some simple drawing tasks. There's also some other really good FPGA tutorials on Twitter that I follow, so I need to pull those together and port them to MiSTer, or have that be the project to port them to MiSTer. And so I think the way I see it is twofold. Like, I think it's impossible to start just build a really complicated core. I mean, people have done it. I'm impressed. But I think the way to do it is, simple core like blinking the lights, but in the MiSTer framework, which is probably using some of the framework, and then taking tasks from people that are kind of maybe boring, but what you'd feel accomplished that need to get done, like the same high score module to 6 arcade games. And I think that's the way we can try to scaffold people up. And then what I'm wondering is if we can get, I would love to know about and have a tutorial from Robert on how he does the emulation and how he simulates it. And I think I think what we could do maybe is bring different members of the community. Like Frank Bruno just wrote a book. He's a SpaceX guy. And that book, I've read most of it. I put a review up on Amazon. There's also the 8-Bit Workshop stuff, and their book is really cool. So it may make sense to bring in other people or other resources, and I think have a session or maybe a blog or a GitHub, walk people through.
There's a lot of us that
different topics.
Yeah, it's a lot of topics to cover, and there's different ways to learn, and I've been impressed by people that can learn from theory, and I deeply admire the work that you guys do, like also the approaches. But there's people that understand things by doing, and there's people that understand things by learning first and doing later. But it's important that one understands on which side we have a preference, because it's not like we are purely academic or purely practical. You have to be in this loop, right? I don't know. That's how I feel, and I believe that we need to cover both sides of the spectrum in some way. Having the documentation is really good for those that can understand from reading, but maybe, I don't know, having like a live stream of set up the development environment for MiSTer, and people could follow along, right? And just set up and build it, and build up a very, very simple core. And that would give confidence and a follow step for people that are more practical. What do you think about that? Would that be possible? Could that work?
I think we could do a live stream or a Zoom and record the Zoom and then maybe edit it. I think just trying to pay for Zoom, so I feel like I should use it. I think you're exactly right. And for me, I'm much more hands-on person and like to hack and get my fingers dirty. And I then have to come around. That's where being in just a chat with SpaceX guy was helpful. And then reading his book, because I had been making so many mistakes and so many problems, like I read his book, and a couple of the things in there were like, oh my gosh, now this makes sense. Now I understand. So I think you're exactly right. We need to get something going, get that blinky light, something accomplished, then do a little more theory, especially with the hardware, because as software people, we generally don't have these same hardware concepts. And then spiral again and make something a little more complicated, and then do a little more theory. And especially with, and then people, you have to get deep into something where then, as I said, the hard part about doing all these computers or games, like, the links and all the stuff Robert's done, is you really have to understand how it worked. So there's usually 20 hours of just staring at, like for me, the serial chip was so complicated in the Mac, they used to Sun and other computers. It's just staring at that manual, and then eventually, boom, it clicks, and then you understand how it works. Then it's just feels great. So there is a lot of boom, but it also means that our community is awesome, because if we wanted to tackle something together, then one person could really work on the serial chip, as silly as it sounds, and another person could handle the video. We could pull together and make something big.
So how do you feel about that, Robert?
I would say some tutorial or live session, that's something that could work. So for small things like blinking LEDs or something like this, this could work to get new developers into doing first FPGA work. Yeah,
like having people have a virtual machine, or have a clean setup and install everything from scratch, and they can experiment there. Having the build environment is something that some of us find daunting or scary, and that could help, like being a first step.
There's one thing about the framework there already. So I would say if you start with the complete framework, the compile takes some minutes. So this will chase away some new developers, I would say, because if you don't have a simulation, you need to build every time you want to change, for example, a small fix you want to do. You don't know what you're doing at the start. So you try something and you wait 6 or 7 minutes to try it on the board. So this would have made me crazy when I started. So when I began, I had a very easy board, and the framework was nothing, just an empty file, and I could just output whatever I wanted to the pins. And the building took, let's say, 20 seconds for this FPGA. So I could type in the code, wait a short amount of time, and see what it does on the board. And I think
that's better.
Really helpful to have. But
I think
it doesn't bring you into the framework yet. So that's 2 steps, I would say.
The framework, I think, right now is, 6 minutes or something? It's like 6 minutes or something to compile the template.
What?
It's less?
He mentions...
Well, Robert, I was just saying I'm agreeing with you. I think it's, 6 minutes or something to compile just the template core.
And, well, regarding that, Do you need a fairly modern computer to do that?
I would say it doesn't matter too much in the end. So if it takes 6 minutes or 10 minutes or 4 minutes, you can't really wait on that. If you're doing something else, if it takes 5 minutes or longer, you don't stare at your screen and wait until it's done. Usually, you wouldn't do that. So you get your thoughts are out of the things you have done. You maybe switch to something else. You come back, and it's really helpful to have things. You write it down, you test it, you write something else. So I would say this really helps getting the loop of improving the first steps much faster.
Can I ask a question? Robert, do you said you write a software simulation for the platform. You wrote links from scratch in a 6502, I think is the processor in there, and everything?
Yes.
And then do you write the core and do you simulate it and simulate the whole core? Or do you go straight to the FPGA?
I fully simulated, including booting into the games and outputting the image before I even started the first time on FPGA.
And you do that in Verilator, or what tools do you use for that?
ModelSim I'm using.
Okay. And
So
when
Verilator, I'm using VHDL, so there's it's
got
the
it.
best tool I know of for that.
And which one do you use in GHDL, or did you say, or which?
So I'm writing my courses are all written in VHDL, so ModelSim is the best tool, I would say.
ModelSim. Oh, sorry, ModelSim. Okay. And then do you hook or do you write your software simulation in a way that you can reuse parts with the HDL, or do you have the software, you figure out how things work, and then you go straight to VHDL?
So what I do is when I write the software emulator first, I have an export of pretty much everything. So let's say every CPU register, timers, EMA register, whatever, to a text file for every clock cycle. And I have the exact same output for the FPGA simulation in VHDL, the same output. And I compare then with a compare tool to see for every cycle if it behaves exactly the same as the software emulator I have written. So the software emulator I have written for the Lynx core, for example, it's very, very slow. So you would expect a Lynx core emulation on a PC, it runs, let's say, 10 times speed, but mine doesn't. It runs maybe, if I'm lucky, if I have luck with a game, it runs at 100% speed. So it's very slow because it calculates every single cycle. It behaves much like Eigen for the SNES in this area. So for every clock cycle, I can do the export, and I do this in VHDL with the simulator, compare them, and see if they behave the same. And if they do, until, let's say, I'm so deep into the game that I can see something, then it's time to go to the hardware, because it should work.
That's really cool. It's really cool. Now, have you built any of these where you hook the ModelSim up like you would write, let's say, just processor in ModelSim and then use the software for the rest, or not sort of do it modularly that way? You tried to like, you haven't, okay. Cause I've been thinking for some of the more complicated computers of, I noticed that the way they got the SCSI hard drive working on the Mac was they actually simulated the Mac using the software simulator, and then they just sent the bus calls to a simple little simulation, and then they wrote the Verilog for the SCSI, and that way the Mac ran it real time, and it just was simulating like just the SCSI chip and the SCSI controller. And I just thought that was interesting. But the problem is to use existing emulators, as you can imagine, is really, you end up having to write your own because they aren't gonna have the right interfaces to look like hardware.
Yeah. So getting the interfacing there, it's really difficult. So I haven't done this.
Okay, I was just curious. Yeah.
Oh, that's really good. From the chat, we get if always choice matters. Do you have an OS preference, or do you believe that it should be in a certain OS to have access to everything, all the tools?
Was that a question
Oh,
to me?
to both of you. If sorry, I didn't address it directly, but now, Robert, do you believe the operating system choice for development is important?
So I'm probably one of the rare cases who only works on Windows systems, so I cannot really comment on that. I have run into several issues with it, with some software not working well there, or being difficult to compile there, but I haven't worked on anything else much in the past, so I only feel comfortable with it.
I've run Fortis started on Linux. I've been, since quarantine, I'm not at home, I've been using Windows. I find the Windows, I think, a little bit easier to hook to the board to get it to debug sometimes, although I have gotten it to work. And I've run it on my Mac, 2 different ways on my Mac, which is crazy. And in fact, when I've gone and done speed tests, the Mac's not really that much slower. So it's totally doable. I would much rather be on Linux, but I'm actually quite happy in the Windows environment now. I've got it all working. So I would say the answer to your question is it doesn't matter at all. I think, and especially because the compiles take 6-10 minutes, I think you can be in whatever you're comfortable with. MiSTer, the C side, if you want to work on the firmware, it compiles under Linux, it compiles in a Docker, it compiles on Windows. A little trick. But I don't think that there's any... I don't think it matters. I think people can do it.
That's really good to know, because it opens up everything to the community.
Everyone.
And you were talking about how you handle those 6 minutes compile time, right? And do you feel that you lose focus, or you get used to it, or you could be doing something else? I believe that I would find a bug in my code while I am waiting for the compile and rebuild eternally.
That really happens from time to time. So you insert some debug signals or some probing to find the problem, and until the build is through, you maybe already found it in the code. So the 6 minutes is for more or less an empty project. But if you go for the larger course, it easily takes 15 or 30 minutes there. So you really have time to search for yourself.
That makes it a really interesting case of detachment in a way, and also analysis, right? For when you're ready to build something and just like build procedurally. I tend to, when I develop in C, I tend to compile every single function, right? And that's not the way that this would work.
But it works this way if you are working together with a simulation, in fact. So it's the main reason I'm doing this, because in simulation, you often have the result in maybe 10 seconds or 20. And that's great. The simulation itself is really slow, but it compiles in like 2 or 3 seconds, a whole project, and you can run it. And if there's a problem, you maybe see it fast. And if you only work on the hardware, you have to wait for the build.
It's a strange set of trade-offs, because, as Robert's saying, if you run the simulation, it compiles really fast, but it runs really slow. And the FPGAs, in a lot of cases, were designed for hardware people to run the simulations faster. So the FPGA runs really fast. The other kind of crazy thing is, well, you can also syntax check. If a project takes 15 minutes to build, syntax checking it might only take 4. And so often you'll run it, see the error, like you're saying. You don't necessarily need to stop it, but you'll fix the error, maybe stop it, and never let it get through the 20 minutes, at least for me, because I'm not that good. And And then sometimes, because it's so single core driven, this is all really a problem with the software. I think the software is just kind of lousy. Cordis. For a while, I would compile 3 or 4 arcade games at the same time, because it wasn't any slower, like clock time, than compiling one. But it is interesting, and that's why I was asking Robert about techniques where maybe we, on the software simulation, a regular software simulation for most of it, and only do the hardware simulation for like one chip at a time or one part. But it's hard to get that to work right.
Well, to speed things up for the Lynx core, I had a technique implemented to have save states already there when I did maybe 10% of the core. I already had them implemented. So I could create a save state in the software simulator, in the emulator, which is
that's really clever.
Maybe 1,000 times faster. You can get to whatever point you want, and you load this save state into the FPGA simulation in ModelSim, and you are directly at this point. So you don't have the problem of slow simulation, because you are already there where you want to go. So maybe I take the save state 10 CPU cycles before. I'm already there, and I can compare what happens.
That's awesome.
So I have cut all this time away.
And the bug fixes too. I mean, I'm super impressed with your save state and rewind and fast forward, because you have fixed so many of the by adding this amazing feature that the community loves, you've made it so much easier to debug, right? Someone can send you a save state and you be right in the right place to find the bug. It's amazing, right? And reproduce it. It's just great.
And also helps while development, as he mentions, right? Because he could just get the save state in hardware and debug it in software, in the simulation. That's really nice.
It's fabulous. Yeah.
And regarding that, we didn't touch on the what kind of skills people would need would help in it, in, like, I don't know, scripting, or would you recommend having certain background for going into this? What would help? Alan?
I think no. I mean, I think just try it and see if you love it. And no, I don't think you need a particular background. I think I'll put something together and work with Senshin to announce it, and we'll
That's
just
awesome.
see who, we'll just try it. And I just recommend everyone try it, whether they think they can do it or not. And we'll try to get a group of people, and we'll do some of this. We'll take Robert's advice and try to do something blinky simple that compiles fast, and we'll move from there.
That sounds great. I'm guessing you don't think there's any other requirements, Robert, or do you have any other opinion on that matter?
I would say if you not really hated math at school, you're probably you can probably do it. If you have always hated math, it's maybe not the thing to do for you. But also one interesting thing I always noted is that the people who like to play games have some way of logical thinking, and that really helps development of this hardware logic, also thinking in this way.
Yeah, it kind of it's interesting that many of us started as players and ended up as developers in some way, right? It's not always the case, because I also have other people at college that didn't play games, but the most passionate ones, I'm generalizing, of course, but tended to feel like to be the kind of people that loved the logic in games, right?
I think that's it's not uncommon.
Yeah, it's not uncommon. And well, another question that I had is regarding the. I already think I know the answer, but people in the audience would probably be interested. Do you play in your MiSTer? Do you play games, or do you only use it for development? I understand that that's difficult in general, but What's your approach?
I don't play nearly as much as I should. I keep thinking I should hook one to a TV. I do want to put it. I'm thinking about getting one of these JAMA boards and getting a cabinet. I think I should. I need to get it on a big TV or something.
And you, Robert?
Yeah. I play some games from time to time. I played quite a lot of games when the GBA core was done. Played some of them when the community said this is a great game. For example, the Castlevania games were often discussed when the GBA core came out, and I never played them before. So I thought I look also into them, and I also played them, and some others too, but not much recently.
And regarding that, has there been a game that has surprised you in terms of how it used the hardware and had you wondering how they do that, even though you worked on the core? Has that ever happened?
That's really interesting. I often, when I play a game, I think about how does it internally work now. So I know how the system would work, but how does this game do these effects or whatever inside the game? I often think about it when I play it. And unfortunately, I often don't have any solution for it. So just doing the base system doesn't mean you understand how the software is using it.
Yeah, of course. And the same thing happens the other way around, right? And Alan, you mentioned the JAMA adapters, right? Like MiSTer, GMX, and other JAMA board adapters. Do you have a cabinet?
I have a MAME cabinet that's not like a real cabinet, and I have, actually have my only real game is a MiSTer Do cocktail. I would have to get a cabinet, and it was so exciting to see the MiSTer Do come out, even though I have one.
Yeah.
It's so
have
fun.
you? I saw you were active in that, and what do you can you tell us about that development? Because there was a lot of kernel fixes for Linux, right? The bouncing. What kind of work have you done on that side?
On which side?
For these kind of adapters.
Oh, I don't. Well, I mean, I think someone was it Antonio or someone sent me one of the first adapters, and it had a kernel problem that with the joystick adapter he was using, it didn't look like two joysticks. So I fixed that. That was trivial. Luckily, it was just uncomment one line in the kernel. But otherwise, no, I haven't worked on those boards. It's the flip that's the issue, right? So the problem is the tape mode with the counterclockwise and clockwise issue. And so that, a bunch of people have been complaining. And so it's something that we've always said, and Alexi's always said, like, oh, it's not possible. The games didn't do that. And it's true that originally the games just randomly were mounted one direction or the other. I took it upon myself to try to add flip for a couple of games that didn't have it. And then Black Wine came out of nowhere on Twitter and did some of the harder ones. And like Pac-Man was driving me crazy. I couldn't get Pac-Man working. But it's been great. I think we were going to go for a clockwise flip, but the new arcade games are all counterclockwise because we just did the math and most of them were clockwise. We thought, okay, if we can fix the last few counterclockwise, at least you could set your monitor one way. But now I think it's going to work I think we'll have almost all of them flipped. A couple games are really not possible, but
it's an interesting issue. For people that are not familiar with this, I encountered this as a PCB arcade collector. And, you have a cabinet, you have, say, 50 boards, vertical boards, the ones that you have to flip your monitor. And obviously, you don't want to be flipping the monitor all the time. So you have very few solutions. Either you have one of these cabinets that have the CRT mounted with a mechanism to rotate it, because developers or companies didn't have a standard for rotation, like Alan said, either clockwise or counterclockwise 90 degrees, right? And the other solution, aside from having this mechanism on the cabinet itself, is to have switches to flip the joke. That's what I ended up doing, because I made this list of the PCBs and said, okay, I have no solution. Like 60% turns to the right and 60% turns to the left, right? And I ended up placing this dual flip switches to switch the joke. but that's not a solution that I'd recommend to people. And the solution here is to have it, the MiSTer flip it. And what's the philosophy? Because this is not something that the original hardware did. They sometimes had dip switches to flip the game, and sometimes even in software, well, soft dips from that were saved to EEPROM that would allow the game to be flipped in either side. But this is like MiSTer has made it in many ways, right? Improving the hardware in some way to have quality of life services. How do you present this to a user? Is it a common front to have it like this is what the original hardware does and this is the improvements? How is this presented?
That's a good idea. We haven't really separated it. The same with the high scores. It's kind of funny because people would put a high score save kit on some of these machines or a pause button, and you did something with the yoke. So I think people have always modified these. So these are kind of, like you said, quality of life modifications. I haven't thought about separating. We could totally label them, separate out like what's original and what's
thinking from a
not.
preservation perspective.
I don't know. No, yeah, I mean, we can. I don't know how important that is, and it does. Yeah, and it does bother me a little bit where, yeah, sometimes we go into the graphics code and really put some modifications into, subtract the height off of everything or whatever.
Yeah.
But a lot of them are not so bad because they have cocktail modes, and a couple of them, all I had to do was basically invert the cocktail mode, and then everything flips upside down. So sometimes it's really easy.
And how do you feel about this, Robert, about improvements to the hardware? Robert?
So to improvements to existing
Yeah,
hardware.
like
So,
in the core.
Going beyond beyond the possibilities of the real hardware. So this is something that I'm really interested in. So some of you have maybe seen the HD mode for the GBA core, and this is one of the features I really love to work on. So doing something the original console was never able to do, and I really like to work on such things. But it should always be optional, of course. So you can go back to the original feeling.
Yeah, I fully agree, and it's I believe that if we have the possibility and the will to do it, it should be explored. And having it doesn't mean that it's not proper. You can always place it as an option, as mentioned before, and have it both ways, right? We can get it both ways.
Yeah, it should always be an option, and usually you have that. I'm not aware of any core that has such features, and it's not you are forced to use them.
In a way, fast forward and rewind are exactly that, and save states, right? They're extensions to the hardware.
Yes, that's something that the hardware is not able to do, but it helps the user in a way to get a better experience from the system. Not sure if rewind is really in this category, but fast forward is for me. It's really important for me, as I've used emulators so long now. And the first thing I search is how can I skip those cutscenes or text boxes or whatever to get a better feeling of the game. So I don't like being forced by the game to watch something or such things. So I really like to go over that, and it's really an improvement to make better experience. Not for everyone. I know that not everyone will like that, but those who do like it should be able.
Yeah, I fully agree. So we just passed the 2 hour mark. I know that's what we had scheduled. I can stay longer if you want to, but I understand that people have things to do and we are in different time zones. So how do you feel? Do you have any stuff? We have a lot of stuff in the list that we could discuss, but any, I don't know, closing points, or how do you feel, Robert?
I think it was a great discussion, and really like this round here.
Good. Alan, do you have any stuff to cover? I have tons of stuff and tons of questions, but I understand. What would you like to tell the audience here?
I just want to thank everyone for coming and listening, and I wanted to thank everyone who's been helping with MiSTer and working on the arcade projects with me. The usual folk, Mr. X, Jatego, and Dar, of course, who've done most of the cores, and Pierco, who's on fire recently with all of his new cores, and Ace and Null Object for his, and Mike Coates, who helped me on Space Invaders and all the audio stuff. Jaguar, who's done all those fixes for Centipede and Millipede. Alex, who did that Gauntlet core, which is amazing. That thing is great. Darren, who finally did Mr. Do. Shane's fixed a bunch of stuff. And then SpaceX guy and everyone else. And if I missed you, I apologize. But it's been fun working with everyone all over the world. And I think this project's super fun.
Yeah, and it's been amazing meeting so much people interested, and I don't know, such a positive community. And I know we can stay here for hours, but maybe we shouldn't. I don't know. I don't know about you, but thank you. In regards to whatever we choose, thank you both for your time, and thank you both for your work. I really admire what you've done. There's so much that we haven't covered yet, like the speed up and cache for the AO46, and all the cores that you've held with Alan for arcade. There's so many of them that I love, and so much work on TRS and the Coco. And we didn't cover the Game Boy and the frame blending and the chess core. There's so much stuff to go over. So thank you in for everything that you do. We really appreciate it. And there's also the channels. You have Twitters. You have Robert. You have a Patreon as well. We'll have that posted if people already have them, but we'll post them. Thank you, Robert. Thank you, Alan.
Thanks for having us.
Yeah, thank you.
Well, thanks to everybody. Thanks to Sentient. Thanks to Risha and everyone on the chat and the community. And I hope that we have another program like this. Thank you.